Let's do a quick recap of limits of infinity and L'Hopital's rule. Limits of infinity, there's three cases. Let's look at the first case where as the limit as x goes to infinity, let's look at 2x plus 5 over 3x squared plus 1. So in this case, we're concentrating on the leading coefficient of the top and the bottom and comparing the exponents. So I've got an x on top and an x squared on bottom. We're going to take the largest exponent on the bottom and divide through by it. So we've got the limit as x goes to infinity, and we're picking x squared. I'm dividing every term by x squared. And you always pick the largest exponent in the denominator. So here, you can simplify it a little bit, just so it's a little easier to see what's going on. We're going to end up with 2 over x plus 5 over x squared over 3 plus 1 over x squared. So when we take the limit and you plug in infinity in for all the x's, just think about if I plug in a really big number into the denominator of a fraction, that whole number is getting really, really, really small going towards 0. So this is going to go to 0, this is going to go to 0, and this is going to go to 0 when I take the limit. So I'm going to have 0 plus 0 over 3 plus 0, which leaves me with 0 over 3 or just 0. And that is always going to happen when the degree of the denominator is bigger than the numerator. You will always end up with 0 as your answer. The second case is if the degrees are the same on the top and the bottom of the leading coefficient. So let's say we've got 2x squared plus 5 over 3x squared plus 5. So almost exactly the same, except now I've got an x squared on top and an x squared on bottom. So we're going to do the same method. I'm going to divide through by the largest exponent in the denominator. So 2x squared over x squared plus 5 over x squared over 3x squared over x squared plus, well, I guess that should be a 1. It doesn't really matter, but so I have 1 over x squared. So same thing, we can simplify a little bit. The 2x squared over x squared, the x squareds will cancel, so leave me with 2 plus 5 over x squared, and that'll be 3 plus 1 over x squared. Now, when I evaluate the limit, this is going to go to 0, and this is going to go to 0, which will leave me with just 2 over 3, which just happens to be the ratio of the leading coefficients. So if your degrees are the same, you're always going to end up with an answer of the ratio of your leading coefficients. Now the third case is if the degree on the top is bigger than the degree in the denominator. So let's say we have 2x cubed plus 5 over 3x squared plus 1. Same method, we're going to choose the largest in the denominator. We're going to have 2x cubed over x squared plus 5 over x squared over 3x squared over x squared plus 1 over x squared. And when you simplify, I've got 2x plus 5 over x squared, 3 plus 1 over x squared. Again, these two terms are going to go to 0, But this 2x on top, when you plug in infinity, 2 times infinity is infinity over 3, which is infinity, which means your limit does not exist. So those are your three cases. It's either going to be 0 if the bottom is bigger than the top. It'll be the ratio of the coefficients if they're the same. And it'll be does not exist if the top exponent is bigger than the bottom. Now let's talk about L'Hopital's rule. You use this if you're taking a limit and you get 0 over 0 or infinity over infinity. That's the only time you can use the L'Hopital's. And it says that the limit as x goes to c of f of x over g of x is equal to the limit as x approaches c of f prime of x over g prime of x. So you're going to want to evaluate the limit first, and if you get one of these two answers, that's when you're going to apply L'Hopital's rule. So let's look at the limit as x approaches 0 of e to the 2x minus 1 over x. So if I plug 0 in, just straight substitution, e to the 2 times 0 minus 1 over 0, this is going to be e to the 0, which anything to the 0 power is just 1, which gives me 0 over 0. So that's when I know I can use L'Hopital's. So I'm going to have the limit as x goes to 0 of e to the 2x minus 1 over x equals, and I'm going to put the little L to show that I'm using L'Hopital. I'm going to take the derivative of the top, which is going to be e to the 2x times 2, or 2e to the 2x minus 0 over 1. Now I can evaluate the limit, which will just give me 2 times 1 over 1, or just 2. So L'Hopital lets you actually take the limit if you get 0 over 0 or infinity over infinity.